Hi, my name is Harvey. I'm doing my final project on Opscode Chef Server. During this project, I will discuss the various aspects of Chef, and hopefully you take away something cool. So, what is Opscode Chef? It was developed in 2008. Chef is described by Opscode as a systems and cloud infrastructure automation framework that makes it easy to deploy servers and applications to any physical, virtual, or cloud location, no matter the size of the infrastructure. I like to think of that as infrastructure as code, and thinking of your infrastructure as an application that you're building. It's also been described to me as server or workstation craftsmanship. So instead of having your ops team doing manual provisions of machines and ad hoc changes here and there and having kind of a calamity of errors in your and differences in your infrastructure, you can begin to code all that and really help and make things easier for other people that might need to take things on down the road. You can read more about the overview of Chef at docs.opscode.com. Why use Chef? Chef creates order. Chef ensures that all systems are configured with what they need the first time across the board. So you don't need to keep a giant list or something where you need to do everything, and sometimes you might be tired and you skip over a piece here or there and the server doesn't have this and it fails in production. You don't have to worry about that, because if everything's coded correctly the first time, it'll always be right. Because everything is coded, it's version controllable, and if you use Chef alongside Git, you can ensure you can roll back if something goes wrong, if a change does go wrong, and you can also mitigate the risk of completing actions manually on a server. So instead of having somebody make a change in production manually, they make the change into the code, and if the code passed tests, then it gets pushed into production. So essentially you're kind of keeping your environment safer. It is also idempotent, meaning that changes made by Chef are only made as needed, and you can run a recipe multiple times and the result will always be the same. You can scale rapidly and, even more importantly, accurately. If you work in a rapidly changing or large infrastructure, Chef brings simplicity to the sudden changes that may require you to provision more servers and have more applications ready to go in an instant. Right now, what you're seeing is a Chef workflow diagram, and it's kind of busy, but the main things I like to take away from this diagram is that things start here in a repo. This is where all your code is. This little guy uses knife, which is a tool, to interact with this box here, the Chef server. And the Chef server creates these nodes, which are just servers themselves. They can be in AWS, they can be VMware, they could be in your own data center. Wherever your servers are, Chef can bootstrap them and have them ready to go. Common terminology: a node is any server or workstation that is configured by Chef server. Chef client is another term. It means it's run on every node to bootstrap a node. What that means is that the first step of Chef server or Chef in general is to install Chef client and bootstrap that node. It's a very important piece of the whole puzzle. Knife, as I've said, is a command line tool to interface with the Chef server. A role defines the type of server it will be and what cookbooks should be run. So anytime you create a server, let's say you want a bunch of WordPress servers, it would be a good idea for you to create a WordPress role. And then within that WordPress role, we'll go to the next common terminology called run list. You would have a run list of the recipes that need to be run for that role. So for a WordPress blog, you would want to have a MySQL recipe or a PHP recipe, an Apache recipe that go hand in hand with what a WordPress server would need. Cookbook is the fundamental unit of configuring nodes. And within a cookbook, you have an attributes file, which has specific settings to be used for a node, and a recipe file, which is a Ruby file that defines and configures a node from top to bottom. Looking more into cookbooks, like I've said, cookbooks contain attributes. They contain file distributions, meaning if you need to have a certain file on a bunch of servers, you can define that in your cookbook. They have definitions that allow the creation of reusable collections of resources. They have libraries that extend the Chef client or provide helpers to the Ruby code. They have recipes that specify which resources to manage and the order in which those resources will be applied. You have templates, which essentially are templates for files you may need on other servers, particularly configuration files. This is really good if you have to have a configuration file or that needs a certain syntax every time. You can specify that in a template and it'll always be right, that configuration file. But it'll also be dynamic because there are a lot of dynamic variables that change within configuration files. So that's why you need those templates. You also have versions and the metadata about recipes, including dependencies. So for example, as I alluded to before with the WordPress analogy, if you had a WordPress recipe, you could write a PHP recipe and a MySQL recipe and call those recipes as dependencies of your WordPress recipe, meaning that if you ran your WordPress recipe, it would automatically run your MySQL and PHP recipe. Metadata also is dealing with your supported platform, so whether the recipe supports Debian, Red Hat, Windows, and so on. And you can read more about the essentials in cookbooks at the link below. Here's a small little recipe example. Recipes can make things very simple. At first, it may not look like much. Apache, you see package Apache2 do, and then package name node Apache package end. So the node Apache piece above is calling an attribute in the attribute file, and the attribute is default Apache package equals HTTPD. So if we put it all together, that statement above is package Apache2 do, package name is HTTPD end. So essentially what's happening is Apache2 on Ubuntu, maybe HTTPD on Red Hat or CentOS. So it just kind of adds the benefit of being able to make this particular recipe across platform. And what it's doing is simply installing the package Apache2 or HTTPD. And the good thing about that is because of the portability of this, you can be assured that if you have a bunch of Linux servers that have different flavors, that this particular piece of a recipe would work. So knife, common knife commands include knife bootstrap, which installs Chef client on a target node. Knife configure creates the configuration files knife needs to work with the Chef server. You have knife cookbook, interacts with cookbook's on your local repo or the chef server, and then Knife Cookbook site, which interacts with cookbooks on the community site, which is one that I will use a lot in the demo where we'll do. Knife Search, which queries the chef server. Knife Roll, which creates and manages roles on your chef server. And Knife Status, which will display summary of nodes on a server. And there are different types of chef. You have Chef Solo, which is essentially Chef Client designed to bootstrap individual workstations. So it's a much more scaled down kind of designed to be used in a solo or isolated type fashion. You have Hosted Chef, which is kind of their flagship, and it's essentially Chef Server is implemented as software as a service, and it's a tool that you can bootstrap nodes from this SaaS tool, and you have like 24-hour 365 days a year support from Opscode, and it's really useful, but not always the cheapest option. So they also have open source Chef, which is a free version of Chef Server, and essentially the main caveat is that it's your own Chef server. You manage it locally on your own server, and you don't really get that much support from Opscode. You can definitely pay for more, but they kind of leave you out there on your own a little bit. But there's tons of resources out there, and I know people that use open source Chef in really amazing ways. So without further ado, it's demo time. And as I alluded to earlier, my demo will actually be in Chef Solo, because Chef Server is a little bit more of a complex beast. It also makes you use your AWS keys, so it exposes your AWS secret key and everything to the public. I didn't want to do that or risk doing that. However, if you want to know how to create a Chef server and provision an EC2 machine, my project does encompass that. If you read my project, you will learn how to do that. It's a step-by-step guide. But my demo will only cover Chef Solo. So the first step is we will launch an instance from the console here. And it can be a micro instance, and we will make sure everything's cool. The security group, if you don't have one, which I'm sure you do, we'll just need port 22, port 80, and port 443. And we will go ahead and launch. At this point, I will be using my Chef project key, which I have made available. Well, maybe it doesn't like that I used a security group with something similar. So I will use another security group that I know has these permissions. So yeah, 22, 80, and 443. That was a weird error I've never seen before. What a time. So again, we have our instance launching. All right. And as that is working, I will SSH into my pre-created Chef solo server with the key, the Chef project key. So at chef.marioharvey.com. Go ahead and SSH into there. All right. So now I am in my Chef solo server, and I will go to a directory that I've already made called Nginx Cookbook. Now, the cookbooks for Nginx are in this directory called Cookbooks, and they're all here. So as you can see all of these are cookbooks, and if I go into Nginx, this is an Nginx specific cookbook, recipes. And this is all of the code. Again, I pulled all of this code from the cookbook site, the Opscode community cookbook site. So all this code was already done. Just a matter of configuring the Chef server. We can look at the metadata. And as you can see here in the metadata, dependencies are listed. Depends on apt, blue pill essential, ohai, run it, and yum. So that's why we have all those other cookbooks, because they were all dependencies. All these cookbooks were dependencies of Nginx. So this is the directory I need to be in to run my commands. So the first thing I need to do is go back and get my DNS for my newly created instance. And run a command called knife solo prepare. And what this will do is it will run Chef client on the machine that I just created and prepare it for me to bootstrap it with Nginx, because that is what I will be doing. Yeah, again, while it's doing this, sometimes it takes a little bit of time to do the Chef run. This is an actual example of Chef server. This is how Chef server looks. I did set it up, and again, my project does cover how to build a Chef server and bootstrap EC2 instances from a Chef server. So you can look in more how to do that. But again, this is the UI of the Chef server. Here are all my cookbooks listed on my Chef server. Furthermore, while we're waiting, community.opscode cookbooks. This is where I get all the cookbooks that I've used from. So, all right. So looks like it's done here. This is generating node config nodes, and this is my public DNS of the node I just bootstrapped. This is where I need to edit my run list. So what I'm going to do is vim in my instance. You will have, there's going to be multiple different files in that node directory. So you're just going to need to find it by your public DNS. I found mine. The run list is completely blank. So I'm going to add nginx recipe. It's very simple to do. It's quotes recipe square bracket nginx. And this is a JSON file. A lot of Ruby utilizes JSON to pass different parameters and things like that. Both square brackets, closing square bracket, closing curly brace. Looks like everything's good to go. We'll definitely see here in a second. I go ahead and save that. Once it's saved, we run another command called knife solo cook. And before I do this, I want to show you exactly right now. If I go to my DNS right now, it's going to fail because there's not a website, it's not listening for anything. So now when I run knife solo cook at my node, it will bootstrap it with the nginx recipe. Here in a second. This might take some time too. There it goes. All this output is the bootstrap occurring. It's actually configuring nginx. And now it's done. So if I go to my node now, it'll say 404 not found because there's no page in the configuration file to point to, but we know that it's listening on port 80. Essentially, I just have to make those changes for it to listen. So that's my kind of quick demo of Chef and what Chef can do. Hopefully this has enlightened you somewhat if you had no experience with Chef.